Hi there. I just wanted to show you this graph. I believe this is the most important graph you'll ever see. If you understand it, you also see why that is the case. If I had a choice, I would show it in every high school, university, to every political party or whoever is on Earth, because it shows you something about what the Earth has been doing in the past, and it can tell you something about what it will be doing in the future. You know, one of the myths is that life creates its own parameters, its own chemical environment. It's not true. Life is an opportunist. If you don't have oxygen in a room, things will die. Humans will die in it. You know, it's basically, if the chemical composition of the atmosphere and the Earth is not conducive to our form of life, the extent, you know, the type that we are, and we happen to be, we're not going to be living in it. There's going to be other species. There's an opportunity for other species to start operating. It's like keys and doors. If it's the wrong lock, then the key won't work, and it's just bad luck for the key. And so the history of the Earth is basically a history of chemical environment, which creates an opportunity for amino acids and bacteria and higher species to evolve and exist and simply do their thing until something goes wrong, like a meteorite strike or some kind of volcanic eruption or something else, or a gamma ray burst or something, and it kills a lot of species. Simply cannot cope with that. And we have had and I'm always on about climate change and that it's important. Well, we have had a rapid climate change in the past in the history of the Earth. And that's what I'm showing you here in the graph. And it shows you basically how the Earth will respond and what will happen to life on Earth if you have a similar rapid increase in temperature and carbon dioxide. To explain what happened at the end of the Permian era, which is 250 million years ago, and the beginning of the Triassic, in that, let's say, changeover, 85% of all life on Earth went extinct. It's called the Great Dying. In the history of life on Earth, there has not been a bigger extinction than the Permian extinction. And life wasn't really around, it was barely noticeable for about 500,000 to 4 million years on Earth. So after this happened, it really took a long time to repair everything, to make it viable, or make it to create an opportunity for the life that we know today. After the Permian came the Triassic and this period of the dinosaurs, and because they were cold-blooded, when there was a meteorite strike and the Earth went cold, the warm-blooded mammals had an advantage, and so we started to dominate. To be very, very short about what happened at this border, if you read into it, is to say, well, the oceans went anoxic, there was no oxygen in them, and because of that they started to emit toxic fumes, mainly hydrogen sulfide. Hydrogen sulfide killed everything. It's a toxic fume, you know it because it smells like rotten eggs. It's a swamp type smell because it's the same type of environment. Swamps are anoxic, there's no oxygen. You have different types of bacteria that live in that environment, and you can smell rotten eggs near a swamp, and you will be smelling rotten eggs on Earth if we don't stop climate change in its tracks before it becomes runaway. You're a lucky person if you smell that, because human, let's say, smell sense is very sensitive to this type of chemical, because a little bit more and you're dead. You know, it occurs in mines. It's found in coal and natural gas, hydrogen sulfide, and you always have warnings, well, because first you smell it, and then your nerves in your nose will be dead, so you won't smell it, and the next thing you know, you are dead. Tragic, but this is such an important graph because you can really look into the events, and it's not entirely, there's no complete consensus about it, but that has to do, I think, more with the fact that people have not been aggressively trying to find out the truth about it, and second of all, it's 250 million years ago, so it's hard to do that. But what you can find around that time period is that climate change heated up the atmosphere because of volcanic eruptions, and then the methane that's on the bottom of the oceans, that is also today on the bottom of the oceans, evaporated into the atmosphere, and that made it way much hotter, 12 degrees hotter, and it killed the oceans. There was no life in it, no oxygen in it, and as a result of that you got the swamp type chemicals being emitted, and as a result of that all plant life, animal life, everything died. And there's another thing you can see, of course, and that is the carbon dioxide line, just to mention that. And if it's out of the atmosphere, that means that there's oxygen. Carbon dioxide is carbon dioxide, so it's one carbon and one oxygen. Oxygen usually has two oxygen atoms in a molecule. You can exactly see what has happened. In the last millions of years, carbon dioxide disappeared from the atmosphere. And that's why we have so much oxygen in the atmosphere. A lot of it, and there's a second aspect of it, of course, carbon dioxide became carbohydrates. So basically the carbon married the hydrate. That means that also a lot of water on our Earth turned into oxygen, because the hydrogen was taken off and matched to a carbon atom and put into the deep swamps and the deep, let's say, oil reserves. Well, let's not make this video too long, but you see that there's lots of oxygen that has been put into the atmosphere that we are now taking out, not only by burning, because we burn carbohydrates into carbon dioxide and lots of water. You know, you might even hypothesize and try to calculate how much of the ocean level rise is actually due to the fact that everything we burn produces water. But I'm talking way too long. Look into this. I have a link next to this video to a page on which I basically collected information about this phenomena, about this historic event, and let's say the parallels that we see today. There's also a solution, and if you want to work on that solution, let me know. I think it's if this is the most urgent graph you'll ever see, or the most important graph you'll ever see, then the most urgent action we should take is to keep the oceans alive and oxygenated. And there are ways to do that, so look into it, and thanks for listening.